2012, number 3, no calculator. Number 3's used to be calculator up until, I think it was last year was the first time. So now, number 3 is the first of 4 problems without your calculator. So let's see what this looks like. Certainly this looks like something I might be finding areas with, right? Alright, this is the graph of f, not of f prime. Always good to note that early on. So f is a continuous function defined from -4 to 3, whose graph consisting of 3 line segments and a semicircle, centered at the origin, the semicircle that is given above. Let g be the function that's defined in terms of the area under this one from 1 to x. Alright, so part A, I want to find g of 2. Well, g of 2 is equal to, here's the g function, it would be the area from 1 to 2 under the f function. And since I'm replacing that, it doesn't matter if you put t's or not here. I'm going to replace it with x's. But because I'm replacing this with a number, I don't need to worry about the dummy variable issue anymore. It really doesn't matter. This just means what's the area from 1 to 2 under this function. So let's see. From 1 to 2, this looks like it's a line with a slope of -1/2. So this would be the point 2, -1/2, right? It goes from 0 to -1. You could actually find the slope there if you need to, but certainly you need to be able to figure out what the coordinates of that point are. And so this is a little bitty triangle that is a 1/2 base would be 1, and its height is -1/2. I'm finding an integral, not an area, right? Not a geometric area, so I do need to have the negative there. That's -1/4. And then g of -2, that would be the integral from 1 to -2 under the f of x function. And I don't know about you, but running backwards makes me confused, so I'm going to flip that. I'm going to say that's negative of the integral from -2 to 1. And then I can just find my area like I'm used to finding. So let's see. That's equal to, that's that negative sign. The area from -2 to 1. The area from -2 to 1. So this is positive and this is negative. This is a triangle that is a 1 by 3 triangle, so the area of that would be 3/2. And then this is half of a unit circle. Unit circle has area pi, so that'd be -pi/2. Right? And then the negative sign flips those. You could probably leave it like that, but I'm just going to satisfy my obsessive compulsive disorder and write it like that, because I like it better that way. So pi/2 minus 3/2. All right. Now, for each of g prime of -3 and g prime double prime of -3, find the value or state that it doesn't exist. Well, let's see. G prime of x is equal to, the derivative of this is just the f function, right? When I take the derivative of this, that cancels out. And it's the simplest kind where there's no chain rule or anything. So g prime of x really is just f of x, and that means g double prime of x would be the derivative. So that means g prime of -3 is equal to f of -3, and f of -1, 2, 3, that's just that value. That has a slope of 1. That's just 2. And g double prime of -3 is the same as f prime of -3, which just means the slope at -3. And the slope of this thing at -3, that slope of that is 1. So 2 and 1 for those. All right. Find the x-coordinate of each point at which the graph of G has a horizontal tangent line. For each of these points, determine whether G has a relative minimum, relative maximum, or neither a minimum nor a maximum at that point, and justify your answers. All right, I'm going to move on to a separate sheet here. Try to have the picture, maybe I can't do that. Oh, maybe I can do it like this. Let's try. Sorry, technical difficulties. There. All right, so I'm looking for places where G has a horizontal tangent line. This is part C. Well, G has horizontal tangents when G prime is equal to 0. Or in other words, when G prime is just the f function. That's where f is equal to 0, right? And I'm just going to write in a sense G prime is equal to the f function. So where does f equal 0? Well, this function equals 0 here and here. So let's say f equals 0 at x equals -1 and x equals 1. Those are the places where it equals 0. -1, this is going from, since f is the same as G prime, then this is telling us that the slopes of the G function go from positive to negative, from positive to negative, from positive to negative. So this must be a maximum, because f equals G prime goes from positive to negative. And this one is neither, because f, which is the same as G prime, goes negative to negative. It doesn't change, right? It goes from decreasing to decreasing again. So it does have a horizontal tangent line there, but it's not a maximum or a minimum, right? If you're looking at this going, hey, that's a sharp corner. Well, this is the graph of G prime, not the graph of G. They're asking about horizontal tangent lines on G, not on this function. So that's the, certainly they would get lots of wrong answers about that. And let's try not to be counted among those. Part D. For values, x values between -4 and 3, find all values of x for which the graph of G has an inflection point, and explain your reasoning. So D, we want to look where G double prime goes from positive to negative, or negative to positive, or you could say where it changes sign. Well, G double prime is equal to f prime. So we're looking for where the slope of the f function goes from positive to negative, or vice versa. So here it goes from positive to negative. So at x equals -2, G double prime, which is equal to f prime, goes positive to negative. And then it keeps going down here. It looks like the slopes go from negative to positive, right? I'm talking about f prime values now. That is the slope of what we're looking at. They go from decreasing to increasing. So that would be at x equals 0, G double prime, which is equal to f prime, goes negative to positive. And last, here we have at x equals 1, G double prime, which is equal to f prime, goes from positive to negative. Right? That's the definition, where it changes concavity. Notice that the slope doesn't have to exist here for that to be for it to be an inflection point. And the inflection point is where it changes concavity. All right.